So here in this video we're going to do exercise 7.3. First question, sine square 2x plus 5. Integrate sine square 2x plus 5. Apart from all the direct derivatives that we learned from differentiation like sine square x, secant square x, cosecant square x, etc. Other than that, there is no integration for any square or cube terms, or for any power. So whatever you learn from the direct anti-derivative property, those things you can apply. But when it comes to a term which doesn't fit into that slot, we need to take the help of trigonometric formula to come out from the square cube forms. Say here it is sine square 2x plus 5. Cos 2a can be written as 1 minus 2 sine square a. So that means 1 minus cos 2a equals to 2 sine square a. 1 minus cos 2a is 2 sine square a. Hence, integration of sine square 2x plus 5 can be written as 1 minus cos 2 times 2x plus 5 by 2 into dx. Now separate the term half dx minus half integration of cos 4x plus 10 dx. Now, when you differentiate, half is a constant, so that stays out. Integration of dx is x. And here half, when I integrate cos, I get sine 4x plus 10. And 4x plus 10, if we take it as t and use substitution there, you get dt by 4. Well, we will not have time to do all that in this exercise. So I'm going to do, the substitution straight away. So cos integration is sine, 4x plus 10 differentiation is 4. Hence, the answer is half x minus 1 by 8 sine of 4x plus 10 plus c. Second question, integration of sine 3x into cos 4x. Now, this is in the form of 2 sine a sine, 2 cos a sine b. 2 cos a sine b, sine of a plus b minus sine of a minus b. So 2 cos 4x into sine 3x is sine 7x minus sine x. Now instead of sine 3x into cos 4x, we can write this as half sine 7x minus sine x. Now separate the term and integrate. Sine 7x integration is cos 7x divided by differentiation of 7x, which is 7. Sin x differentiation is cos x by 2 because of this 1 by 2 n plus c. Just multiply 7 into 2 and that's it. We get the answer for that. Third question, cos 2x, integration of cos 2x into cos 4x into cos 6x. So we use 2 cos a cos b, which is cos of a plus b plus cos of a minus b. So I'm grouping only cos 4x and cos 6x right now. So 2 cos 4x into cos 6x is cos 10x plus cos 2x. So instead of cos 4x into cos 6x, we'll write half. The 2 comes down. Half into cos 10x plus cos 2x. Now multiply this half properly along with the cos 2x. So half into cos 2x into cos 10x is the first term. Half into cos 2x into cos 2x is cos square 2x. Further, this is again in the product form and use the same formula once again. So you get half into cos 12x plus cos 8x. And this is cos square 2x. Like I told you before, there is no integration for square or cube terms. So we take the help of cos 2a formula. If it's in the form of sine square, we write it as 1 minus cos 2a by 2. If it is in the form of cos square, we write it as 1 plus cos 2a by 2. And here it is cos square. So it is 1 plus cos 4a by 2. The by 2 is taken as 1 by 2. Now take 1 by 4 common out. Start integrating each and every term. Cos 12x integration is sin 12x by 12. Cos 8x will be sin 8x by 8. Integration of dx is x. Integration of cos 4x is sin 4x by 4. That's it. Fourth question, sin cube 2x plus 1. I did this sum in two methods. The first, most comfortable method, whenever we see cube, the first thing that comes to our mind is sin 3a formula. So sin 3a is 3 sin a minus 4 sin cube a. So sin cube a can be written as 3 sin a minus sin 3a by 4. Using this, I'm rewriting sin cube 2x plus 1 as 1 by 4 times 3 sin 2x plus 1 minus 3 times 2x plus 1. And just take the constant out, start integrating them normally as we do. Sin 2x plus 1 is cos 2x plus 1. 2x plus 1 differentiation is 2. Sin 6x plus 3 is cos 6x plus 3. Differentiation of 6x plus 3 is 6. And this way we get the answer. Now, this is not your book answer. So there is another method, since integration can be handled in multiple ways. This is targeting the book answer. Okay. So sin cube 2x plus 1, I am writing it as sin square 2x plus 1 into sin 2x plus 1. Sin square 2x plus 1 is nothing but sin square theta. And sin square theta is 1 minus cos square theta. Therefore, sin square 2x plus 1 can be written as 1 minus cos square 2x plus 1. Now use substitution. Take t as cos 2x plus 1. Differentiate that. Change the question entirely in terms of t. Dx will become minus dt by 2 sin 2x plus 1, which will eventually cancel the sin 2x plus 1. And this will become 1 minus t square into minus dt. Half will come out of the integration. Integrate t function with respect to dt. So we get this as the answer. And in the end, substitute whatever you have assumed as t. This would be your book answer. So next question, which is integration of sin cube x into cos cube x dx. So sin cube x into cos cube x can be written as sin x into cos x the whole cube. And sin x into cos x is part of sin 2a formula. Sin 2a is 2 sin a cos a. So that means sin x into cos x can be written as half sin 2x. Now apply the cube. 1 by 2 the whole cube is 1 by 8. Sin 2x the whole cube is sin cube 2x. Now from here you can even use sin 3a formula and convert it, just like the previous sum. Or I'm splitting it as sin square 2x into sin 2x. And then writing sin square 2x as 1 minus cos square 2x. And then the same process like the previous sum, the OR method. Take t as cos 2x. Using substitution, I can cancel sin 2x and it got cancelled. The whole question is in terms of t. The whole question is in terms of t. After you integrate, substitute t back. Fifth question, I did explain this method now, wherein I missed it too. That has been included in the end. But this is not the book answer. So there are multiple ways to do this question. The second method that we are going to adopt is taking t as sin x. If t is sin x, dt by dx is cos x. So this will become t cube. Dx will become, the dx over here will become dt by cos x. So one cos will cancel with cos cube x. So then it will be cos square x into dt. Cos square x we can write it as 1 minus sin square x. And then since t is sin x, this becomes 1 minus t square into dt. Now multiply t square with 1 minus t cube into 1 minus t square. T cube into 1 is t cube, t cube into minus t square is minus t power 5. Separate the term and integrate. T cube integration is t power 4 by 4. T power 5 integration is t power 6 by 6. Substitute t. But this is not the book answer because the book answer contains cos instead of sin. And there is a minus also. So if we change our assumption from t equal to sin x to t equal to cos x, instead of t equal to sin x, if you opt for t equal to cos x, then you get the exact book answer. T equal to cos x, dt by dx is minus sin x. So in the place of t cube, cos cube, we write minus t cube into sin square x because one sin will cancel with the sin cube x. So t cube into sine square x into dt, minus stays out. Sine square x we write it as 1 minus cos square x. Since t is cos x, cos square will become t square. Multiply t cube with 1 and t cube with t square. So it's t power 5 into t cube. T power 5 integration is t power 6 by 6 and t cube integration is t power 4 by 4. In the end, substitute t as cos x. You get this answer. And this is the book back answer. So there are three ways to solve this sum. Even if you ask me, there's one more way. Instead of this way, if you take sin x into cos x, sin cube 2x in form of sin 3a, even then you will be able to integrate this question. So what is more important is to integrate rather than getting the book answer. This one is sixth question. Integration of sin x into sin 2x into sin 3x dx. So group any two terms out of the three. I have grouped sin x and sin 3x. Using 2 sin a sin b formula, this will get changed to half times cos 3x minus x minus cos 3x plus x. So that is nothing but cos 2x minus cos 4x. We still have a sin 2x left. We only grouped sin x and sin 3x. So sin 2x is still there. So now multiply the resulting answer, the answer that we got, with sin 2x. So half into sin 2x into cos 2x, that becomes half sin 2x cos 2x, and half into sin 2x into cos 4x. So that's over here. Half stays out common. Sin 2x into cos 2x is in the form of 2 sin a cos a, which is half sin 2a. So if it is 2x here, it will be 4x over here. And this one again in the form of 2 cos a sin b, which is sin of a plus b minus sin of a minus b. Open the brackets, take out the constants common out, start integrating. Sum is over. Seventh question, the same way, pretty much the same way like the previous one. So using 2 sin a sin b formula, which is cos of a minus b minus cos of a plus b. So this will become half cos 4x minus cos 12x. Separate the terms and start integrating. Cos 4x is sin 4x by 4. Cos 12x is sin 12x by 12. Multiply the constants, you get the book. Eighth question, 1 minus cos x by 1 plus cos x. 1 minus cos x is in the form of 1 minus cos 2a, which is 2 sin square a. 1 plus cos x is in the form of 1 plus cos 2a, which is 2 cos square a. Therefore, this will become 2 sin square x by 2 cos square x by 2 because of the half angle formula or submultiple angle formula. 2 will get cancelled. Sin square x by 2 by cos square x by 2 is tan square x by 2. There is no integration for tan x, but instead tan square x, instead you can write that as secant square x minus 1. So here, instead of x, we have x by 2. So we get secant square x by 2 minus 1. Integrate secant square x by 2, that's tan x by 2. Differentiation of x by 2 is 1 by 2. Dx integration is x and plus c. So ninth question, cos x by 1 plus cos x. Cos x can be written as cos square x by 2 minus sin square x by 2 using cos 2a formula. Cos 2a contain 4 versions. In that, the first version is cos square x minus cos square a minus sin square a. So using that, but for half angle. So if it's x here, it will be x by 2 over here. And 1 plus cos x, we've been using it now. So 2 cos square x by 2. Now distribute the terms, separate the terms. So cos square x by 2 by cos square x by 2 get cancelled. We'll have only half here. And here we get half into tan square x by 2. Tan square x by 2 is secant square x by 2 minus 1. Multiply the halves. And then you get integration of dx minus half integration of secant square x by 2. Integrate and get the answer. 10th question, integration of sine power 4x dx. Sine power 4x can be written as sine square x the whole square. Sine square x can further be written as 1 minus cos 2x. These are the first 10 questions. Rest of the sums, let's do it in the next video.